Alright, the first topic in this course is describing motion. To figure out what things are doing, we got to be able to figure out how to describe when something's in motion. So, when we measure motion, there are three things we look at. How far, either distance or displacement, how long, which is your time, and how fast, which is basically just the ratio of how far to how long, which is your speed or your velocity. Those are the only three things you got to look for in a question. How long? So time is defined as the time, how long it takes between two events. By the way, I will try in this course to use, every time I use the word long, I'll be referring to time. I'll use far when I refer to space. So for example, 1 second is how long it is between the hand on the clock moving from one point to another. 1 hour is 3,600 of those. Distance and displacement. Now these are different because in physics, how far you've gone and where you are two different concepts. So distance is the separation of two objects. So the distance between two lines on a ruler could be a millimeter or a centimeter. It's a scalar. It only has a magnitude. It's how far you've gone. I don't care what direction. Displacement is the separation of the start and finish position and the direction. So for example, Ottawa is 60 kilometers east of Arnprior, if you want to know where the school that we're teaching at is. Displacement's a vector. So that's important because you need to know where you are, and in a lot of physics, where you are is way more important than how far you've gone, okay? So, they don't always have to be the same either. So for example, if you've got a dog walking 10 meters east, then 20 meters west, then 5 meters east, if you're doing distance, you're just adding up the 10 plus 20 plus 5, and you're getting that the dog walked 35 meters. So the distance the dog traveled was 35. Displacement, though, is how far the dog is from where they started. So 10 meters east and 20 meters west, well, those will cancel out a little. So the way we do it is, just remember, if you're walking west, that's the same thing as basically facing east and walking backwards. So 20 meters west is the same as minus 20 east. So we could write it as 10 meters east minus 20 meters east plus 5 meters east, and you get minus 5 meters east, which means that the dog basically walked 5 meters west. So if you'll notice, distance and displacement aren't always the same. You can walk 35 meters, but only end up 5 meters from where you started. Alright, speed and velocity. Speed is the rate of change of distance with time. It's a scalar. So velocity you find by just speed you find by just dividing the distance by the time. Velocity is the displacement divided by the time. And velocity can be different than speed. For example, if you're going around a circle, your velocity is changing because the direction is changing, but the speed you're traveling at is actually still staying the same. Okay? By the way, if you're not good at rearranging that, what I would really recommend on your little cheat sheet you're going to make for tests and exams is actually write this equation, solve for distance, solve for velocity, solve for time right away. That way you don't have to do it during a test. So, let's look at the last question. So if the dog did that in 20 seconds, remember from the solving problems, you define what you know first. So the distance is 35, time is 20. Write out the equation, plug in the numbers, get an answer. So speed is 1.75 meters per second. That's the unit for speed. Kilometers per hour is another unit for speed, you may know. If the dog had a displacement of 5 meters west, well, the displacement will be 5 meters west. The time is 20. We write out the equation. We plug in 5 meters west divided by 20, so we divide 5 by 20, and it's 0.25 meters per second west. Don't forget to put the direction in brackets afterwards because that's really important which way it's actually going. Units and conversions. So a lot of time we're going to use one of two sets of units, okay? We're going to use hours, kilometers, and kilometers per hour for things that are traveling for a long time, or seconds, meters, and meters per second for things that are traveling a very quick time. So one would be for your car driving, to Thunder Bay. One would be for you running 100 meters. The way to convert is 1 hour is 3,600 seconds. So hours to seconds, you multiply by 3,600. Seconds to hours, you divide by 3,600. Kilometers to meters, you multiply by 1,000. meters to kilometers, divide by 1,000. Okay, for kilometers per hour per meters per second, there's one way math teachers tell you to do it, but there's a much faster, easier way. If you're going kilometers per hour to meters per second, divide it by 3.6. If you're going meters per second to kilometers per hour, multiply it by 3.6. So I would really recommend you take this slide right in here and put that on your cheat sheet, because that way conversions won't mess you up while we're trying to do some of these questions. All right, see you next time.